So for 5.1, our objective is to factor integers and find the GCF, or greatest common factor, of several integers. So for our warm-up, we have to state whether these numbers are divisible by 2, 3, 6, 5, or 10 using our rules. Same thing we did yesterday in the notes and on your homework. So first up, we've got the number 51. We're telling if it's divisible by 2, 3, 5, 6, or 10 using our rules. Lexi, is 51 divisible by 2? No, I would agree. It is not. Tariana, can you explain why using our rules? Right, why not? So what do our rules say from yesterday? How did we know if a number was divisible by 2? Nope, not on this one. It's possible for the ones place to be 0. Let's get out yesterday's notes if we're not remembering our rules. Okay, so because our ones digit is a 1, and that is not divisible by 2, we know that overall the whole number is not divisible by 2. So we could say 1 not divisible by 2. Or you could say the ones digit is not divisible by 2. Okay. On 3, Danielle, is 51 divisible by 3?
No.
Are you sure?
No.
Okay. You don't need a calculator. Use your rules. What does our rule say about divisible by 3?
I don't know.
Okay. Well, I'll agree with your second answer of yes, it is divisible by 3. May, can you help us out with why?
Because 5 plus 1 is 6, and you can divide that by 2.
Beautiful. 5 plus 1, the sum of those digits, is equal to 6, and 6 is divisible by 3, which makes the whole number, 51, divisible by 3. All right. Moving on to the next one. Keep pulling sticks of people that are not here. Keon, is 51 divisible by 5? No, it is not. I agree. Logan, can you tell us why? What does the ones digit have to be for it to be divisible by 5, Logan? What? A 0 or a 5. The ones digit's not a 0 or a 5. Ones digit is not 0 or 5. Okay, so therefore it cannot be divisible by 5. Is 51 divisible by 6, Stasia? No, it is not. Ellie, can you tell me why?
Because you can't divide 1 by 2 and 3.
You're close. We need the whole 2 and 3 part, but it's not just about the ones digit. It's about the whole number. Good. So we could divide it by 3. That one was a yes. But we could not divide it by a 2. So it's not about the ones digit, it's about the whole thing overall. So 51 was not divisible by 2. It's got to be divisible by both 2 and 3 in order for the whole thing to be divisible by 6. Okay. Next one. Deshaun, is it divisible by 10? No, it is not. Jamaro, can you tell me why?
10?
Mm-hmm.
It's not a 0.
Good. One's digit is not a 0. One's digit is not 0. Questions about divisibility rules from yesterday? Okay. Let's go on to number 2 on this one. We'll just go through and say which ones they're divisible by. So is it divisible by 2, Jalen?
Yes.
Yes, it is. Okay, this ends in a number that is divisible by 2. 0 can be divided by 2. It's just 0. Kion, is 100 divisible by 3?
No.
No, it is not. Okay, if we take 1 plus 0 plus 0, what do we get? 1. Is 1 divisible by 3? Nope. Natalie, is 100 divisible by 5?
Yes.
Yes, it is. Our number ends in a 0. The ones digit is a 0, so it's divisible by 5. Jakeem, is 100 divisible by 6? No, it is not. If we crossed off the 3, then it's not going to work. We would have had to have said yes to both 2 and 3 to say yes to 6. And Jeriel, is 100 divisible by 10? Yes, it is. Again, the number ends in a 0, so it will be divisible by 10. All right, so for our notes today, to factor a number over a given set, you write it as a product of numbers in that set called the factor set. We should be familiar with the term factor. What does product mean to us? A multiplication problem. So we're breaking down a number and rewriting it as a multiplication problem. We get those blanks filled in? Okay. So for our first examples, we are going to give all positive factors of each integer. Now the way that I like to do this is by making a list starting with 1. So in order to get 56, I could take 1 times what? 56. Here's where our divisibility rules start coming in handy. Next, I'm going to move on to 2. Can I divide 56 by 2? Yes. 2. So that means that I should be able to find 2 times what number would give me 56. How could I figure that out? Jamal? Divide it by 2. If you take 56 and actually divide it by 2, you could figure out what that other factor would be. Anybody do that? 28. So 2 and 28 are factors of 56. Then I move on and I think about 3. Is 3 going to be a factor of 56? No. So if we go back to our rules, if we were to take 5 plus 6, what would I get? 11. Is 11 divisible by 3? No. So I'm going to skip over 3. Next I move on to, not 5. What comes after 3? 4. We got to do all of them. So if this number is divisible by 4, I've got to put it on my list. Now, here's a little trick Some of you, this will work for. Some of you, you might not like this a whole lot. You've already made your factor pair for 2, right? The number that's paired up with 2, if that number can also be divided by 2, then 4 should be on your list. Does that make sense? So can 28 be divided by 2? Yes. So then 4 should make it onto our list. 4 times what? 14. Okay. Then we move on to 5. Should 5 be on our list? Nope. What about 6? No. Why not? What other number did not make it on the list? 3. 3 didn't make it on the list. 6 can't make it. Okay, then 7. 7 we don't really have a good rule for. 7 you just kind of got to either know that it is or it isn't.
Yeah.
It is in this case. 7 times 8. Now, if I'm keeping this pattern of counting up as I'm going, what would be the next number that I should try?
8.
8. Is there a point in doing that?
No.
No, I already have 8 on my list overall. So once you get to that point where you're going to start reusing numbers that are on the other side of your list, you can stop. You've found all of your positive factors. Questions about that process before we move on to the next one? Okay, let's start that process over. So for 48, I'm going to start with 1 times 48. Next, I move on to 2. Does it work?
Yeah.
Yep, 2 times 24. Is 3 going to work?
No.
Yes.
What's 4 plus 8? 12. Is 12 divisible by 3? It sure is, so 3 makes it onto the list. 3 times 16. Is 4 going to be on our list? Yes, it is. 4 times 12. Next, we should check 5. Is 5 on our list? No. 48 ends in an 8, not a 0 or a 5. After 5, we should check 6. Should 6 make it? Yep, 6 times 8. After 6, I would check 7. Is 7 going to work? No, it is not. After 7, I check 8. Do I need to put 8 on my list again? No, so I am done. We got all of our positive factors for each integer. Questions about how we made those lists? Okay, sometimes you'll see these written out in order, meaning that they'll just count up. So for my top list, it would be 1, 2, 4, 7, 8, 14, 28, 56. If you prefer to write out a list in order like that, separated by commas, that's fine. I like my factors written as pairs personally. It helps me think through it a little easier. But whatever you prefer. If you see them written out as a sideways list like that, it's not wrong. It's just a different way of writing it. All right, who can give me my first pair of numbers for my list? Natalie? 1 times 100, I would agree. I'm going to write it up here since you can't see it very well at the bottom there. Ellie, what's my next pair? 2 times 50, good. Jamal, you got the next one?
4 times 25.
I would agree. We got to skip over 3 and go to 4. Tariana?
5 times 20.
I agree with that. 5 times 20 sounds good to me. All right, then, is it going to be divisible by 6? No, because it wasn't divisible by 3. 7? No, also not going to work. What about 8? No, it's not. So another kind of, if you're good at these kind of checkpoint things, when you divide it by 4, if the number paired up with 4 is divisible by 2, then it's going to be divisible by 8. Is 25 divisible by 2? No, that's why it's not divisible by 8. Okay. All right, after 8, we should check 9. Is it going to be divisible by 9? No. If it wasn't divisible by 3, you don't even have to check 9. Does that make sense? It's not divisible by 3. It's not going to be divisible by 9. Just because it is divisible by 3 doesn't make it divisible by 9. But if 3 is not on our list, we don't even have to check 9. After 9, we should check 10. 10 times 10. If you want to write 10 times 10, you can. But you only have to list it once. So if you just put 10 by itself down at the bottom, that's also okay. Then we've got a full list. Questions? We're okay with making our factor lists? Okay. All right, a definition that I think that you should already know from some time in your past mathematics career is the definition of a prime number. It is an integer greater than 1 that only has 2 factors, 1 and itself. So that means that 1 is not considered a prime number. It's got to be something bigger than 1, like 2 or 3 or 5, 7. Is 9 a prime number? No, because it has other factors. Okay, to be a prime number, it's just got to be 1 times itself. Nothing else would go on the list. To find prime factorization of a positive integer, you express it as a product of primes. In order to do that, we usually make a factor tree. Has anybody made a factor tree before? Okay, hopefully you have. If not, you're about to learn. They're really fun. You'll use them again in Algebra II. Honestly, you use them a little bit again in geometry. So this is a skill that would be great if you could hold on to it for the rest of high school, at least. Possibly into college, if that's where you're headed. Ooh, too fast. All right, so we are going to find the prime factorization of these numbers. My factor trees get a little big, so I'm going to do one at a time on the screen. When we start these factor trees, break 72 into 2 of its factors. So 1 pair. We're not going to make that whole list like we just did. We just need 1 pair that would belong on the list. Not 1 times 72, because that's not going to get us anywhere. So what could I divide 72 by? 2. I know I could divide it by 2. 2 times what? 36. You just got to start somewhere. If you wanted to start with 8 and 9 instead, that's fine. You would just have to work both of your branches. We can stop the branch that has 2. 2 can't break down anymore other than to be 2 and 1. And we never put a 1 on a factor tree. Okay, if you need to make that note to yourself, never use 1 on a factor tree. Never, ever, ever. Don't do it. All right, so we are done breaking down 2, but we still need to break down 36. Somebody new, give me a factor pair for 36. Natalie?
3 and 24? Or
Close. 3 and 12. Okay, 3 and 12 would be a factor pair for 36. So I think, Natalie, you were giving me another pair for 72, right? Okay, so we broke down the 72. We broke down the 36. Once you break down a number, if you want to put a little line through it or a little X through it, you can. Once you break down a number, you're done with it. You're moving on to the next number. Does that make sense? Okay. So that we won't put x's through our prime numbers though. So we won't put an x through 2. We won't put an x through 3 because we're not breaking those down anymore. Can we break down 12 more? We sure can. Somebody I haven't heard from, can you give me a factor pair for 12? Deshaun? 4 and 3. So that's one of our options. If you used a different one, it's okay. We should still end up with the same answer at the very end. Can we break down this 3 anymore? No, we can't break down 3, but we can break down the 4. 4 breaks into anybody? Everybody? 2 times 2. That's our only option. It's got to be 2 times 2 there. So we broke down the 4, so I'll cross that one off also. We did not break down the 2s or the 3s. Those are all prime numbers. So to write out your prime factorization, we would write out 2 times 2 times 2, because I had 1, 2, 3 2s. What do you think's going after that? Times 3 times 3. Okay, so I used up all the bottoms of the branches. What do you notice about the order that I put it in? Least to greatest. That's what I expect you to do. Now, I'm not sure if we necessarily cover this coming up in the notes. I don't remember seeing it. But if I wanted to rewrite this shortened down a little bit, does anybody remember how we could rewrite 2 times 2 times 2? Keon? 2 to the 3rd power. And I could rewrite 3 times 3 as 3 to the 2nd power. So either of these would be acceptable. Questions, concerns about number 4? Did we all get it down because it disappears when I bring back the other one? Okay. Then let's bring back number 5. We'll take away number 4. We need to break down 504, which I'm going to scoot up a little bit so that I've got room for my tree. What can I divide 504 by? Heard a 2. I like 2. 2 times what? 252. Okay, then I have to divide 252 by something. What do you want to use, Natalie?
3.
Okay, we could use a 3. 3 times what? What? 84. Okay, if you didn't use a 3, use something else, that's fine. Our answer at the very end should be the same. All right, we got to break down 84 now. Deshaun? 4 and 21. So this is a situation that we haven't seen yet, so I'm glad we're going here. Again, if you want to cross off the numbers that you've used up, you can do that. You don't have to. Can we break down 4 more? Yes. Can we break down 21 more? Yes. Both of our branches now can keep getting broken down. So that's something we hadn't seen yet. If I break down 4, what do I get? 2 and 2. And if I break down 21, I get a 3 and a 7. Again, if you want to cross off numbers that you broke down, that's fine. That helps you remember not to put them on your prime factorization list. So now, are we done breaking things down? Yeah, we can't break down 2s or 3s or 7s. 7 is also a prime number. So we're ready to write our list. How many 2s are going on my list? 3 of them. 2 times 2 times 2. How many 3s are on my list? 2 of them. 3 times 3. And what else goes on there? That's 7. If you would rather write it with exponents, we again would have 2 to the 3rd power, 3 to the 2nd power. Does 7 need an exponent? No. If I gave it an exponent, what would it be? a 1, 7 to the first. Okay, so either of these would be acceptable as your answer. Questions about prime factorization? Okay. It's a lot to cover today. Here's something that you also should already know about, the GCF. GCF stands for what? Greatest common factor. So if you want to write that out, you can. Oh, it is written on yours? Oh, good. Greatest common factor. It is the greatest or biggest integer that is a factor of all given integers. So you can have the GCF of 2 numbers. You could have the GCF of 3 numbers. You could even find the GCF of 10 numbers if they gave you 10 numbers. Okay. The hint is to find the matches. When they say find the matches, they mean from the factor trees. So you could put that down. So either from the factor tree, or if you list out all of your factors from factor tree or factor list. We'll look at it both ways. 2 different ways we could handle it. All right, we ready to try this out? Did we get that box filled in? Okay. Now, looking at these, you might already know the GCF, right? These are not very big numbers, but just for the sake of practice, we're going to look at how we could find the GCF. We're going to do it 2 different ways, and then you guys can tell me which way you like best. One way is to make your list like we were doing on the first couple examples for both numbers. So if I'm making my list for 12, I would have 1 times 12, 2 times 6, 3 times 4. Do I need to keep going? No, because then I'll just circle back to 4. So there's that list. For 18, I have 1 times 18, 2 times 9, 3 times. Can I use 4? No. Can I use 5? Also no. Do I need to keep going? No, because I've already got 6 on there. So it said look for the matches. What matches could we make here? Okay, they both got a 6. Do they both have anything else? 2. Both have a 2. Both have a 3. They don't both have a 4. They both have a 1. So which one of these do you think is the greatest common factor? The 6. Okay, that's the biggest number that we could find on both lists. So the GCF is 6. That's one way of doing this problem. I'm going to show you another way. You don't necessarily have to write it down. You might want to if you've got some space. The other way is going to be to list out our prime factorization. So if we are first doing 12, what could I break 12 into initially if I'm doing the tree? 2 and 6. I heard some people say softly. All right, and 6 can break into 2 and 3. So my prime factorization would be 2 times 2 times 3. We okay with that part? All right, what about 18? What can 18 break into? Nobody knows. We just made a list. 2 and 9. 9 breaks into 3 and 3. So this list would be 2 times 3 times 3. Now when we're looking for matches doing this method, it's a little bit different. we look at these two lists, any number that you see appear on both lists, you're going to write down. So what's one number that's on both lists? So we have a 2 on both. I'm going to cross those off. We've got a 2 times, what other number can I cross off from both lists? A 3 from both lists. What is 2 times 3? 6. Same GCF, different way of finding it. But you have to match them up one at a time. Why could I not write down another 2? This one still has a 2. This side doesn't have another 2. I already crossed it off. Okay? So if they pair up, you cross them off and you use it one time. This way is a little bit more reliable if you're using bigger numbers, because to come up with all your factor pairs for a bigger number is a little bit harder. Questions before we try the next one? Feel like I need to start going back to the sticks. Maybe we're just getting a little burnt out here. Okay. On number 7, let's go ahead and use the prime factorization way. I think we need a little more practice with that. So we're going to break down both 8 and 24. Houston, what can 8 break into? 2 and 4, good. Jaquan, which of those numbers, 2 and 4, can I keep breaking down? And what does it break into? 2 and 2. So this one we're done with. 2 times 2 times 2. Kelby, what can I break 24 into? 2 and 12. 12 will keep breaking down. Ryan, what could I break 12 into?
6. 2.
Okay, 6 and 2. Jamal Dixon, which one of those will keep breaking down?
2.
And it breaks into
2 and 3.
2 and 3. So my prime factorization here is 2 times 2 times 2 times 3. Now I've got to start matching them up. Nevaeh, what's a number that appears on both of these lists? 2. So I'm going to take 1, 2 from both lists, write it up here. Connie, what's another number that's on both lists?
3.
I don't think I've got a 3 over here on this list. Don't overthink it. What numbers are still written here over here for 8 that I haven't crossed off?
2.
What about over here?
2.
Okay, so I can pull another 2. So there's another 2. Franklin, can I pull any other pairs?
You can pull 2 more 2s.
We could pull another 2, one from each list. So when I pull from both lists, even though there were 2 of them, one here, one there, I only write it down once. Okay, does that make sense? Anything else? No, because I don't even have any numbers left over here for 8. And if I take 2 times 2 times 2, I get 8. So that is my GCF. Again, you could have come to the same answer if you'd made your factor pair lists instead of your factor tree. All right. Long notes today. Do we need to ask any questions before we continue? All right, let's keep it going then. We're all going back in the cup with our popsicle sticks. We are asked to find the GCF of 882 and 945. Now, these are 2 numbers that personally I do not want to list out all of their factor pairs. Right, starting with 1 times 882 and working my way up. That's going to take way too long, and I'm probably going to miss one of those pairs at some point. So instead, we are going to do the prime factorization of it. So if I'm breaking down 882, what could I divide it by? I know I can divide it by 2. 2 times what? 441. I can break down 441. What's it divisible by? Jamal? 3. 4 plus 4 plus 1 is 9. 9's divisible by 3. So is this number. 3 times what? 147. We're about to start pulling sticks. Jamal can't do all of this problem for us. Alright, I got to break down 147. Now, if you know it's not divisible by 2 because the 7 is not divisible by 2, I would check 3. What's 1 plus 4 plus 7? 12. Is 12 divisible by 3? Yep, so that means this number is. I need somebody other than Jamal Dixon and Natalie to help me out with what that would be. Lexi. 49, thank you so much. Hopefully we all recognize 49 because it's only got one factor pair other than 1 and 49. 7 and 7. So I'm going to go up here to the top and write out that list. 2 times 3 times 3 times 7 times 7 is my list, or my prime factorization for 882. Are we all okay with why I didn't put 49, 147, or 441 on that list? Okay, you break them down, they don't go on the list. Now we need to break down 945. Ellie, what is something I could divide 945 by? 3. Okay, 3 times what? 315. I agree with you there. Then we can break down 315. Deshaun, what's something we could divide 315 by? 5. 5 times what? 63. Sounds good to me. All right, we're down to 63. Tariana, what can we break 63 into? Three and 21. Good. And then we still need to break down 21. Keon, what does it break into? Keon? We're just breaking down 21. So we finally came to the conclusion that 21 gets broken down into 3 and 7. Do we all understand that? Wonderful. So if I write my list for 945, how many 3's do I have? 3 of them. Also a 5 and a 7. Houston, what's something I can pull from both of those lists? I can pull a 3 from both lists. Jaquan, what's something else I can pull? Another 3. Jamal, what's the last thing I can take? 7. Then I have to multiply 3 times 3 times 7. Ellie? 63 is my GCF. All right, we ready for the next one?
Yeah.
Okay. List all positive factors of 30. When we're listing the positive factors, that's when we make our list, starting with 1 times something. Tomorrow, what would 1 times something be? 30. May, what's next on my list? 2 times 15. Natalie, what else?
3 times 17.
We're dividing 30.
3 and 10.
3 times 10. Is 4 going to work? No. Jalen, what goes next on this list?
5 and 6.
5 times 6. All right. Do we need to keep going on that list? No, we would circle back to 6. So we don't need to keep going. Next, we've got the prime factorization of 98, which means we have to start breaking it down. Kion, what can I break 98 into?
1, right? Or 2?
No, if we're doing the prime factorization, we're doing a tree. We don't put 1s on trees.
So 2.
So 2 and
2 and let me divide that right quick.
okay.
Pen not working. What's that? 49.
2 times 49. We can keep breaking down the 49. Nevaeh, what does 49 break into?
16. 3 times 16.
That would be 48. We're doing 49.
Oh. Oh, 25 divided by 2 times 25.
We're trying to break down 49. What 2 numbers?
7 times 7.
7 times 7 is how we get 49. Do we need to break those down anymore? No. So our prime factorization is 2 times 7 times 7. All right, we got to find the GCF of 66 and 90. I'm going to collect that when you arrive tomorrow. So write that on another piece of paper and make sure you get your homework done. Page 186, 2 through 46 even. You're lucky I'm not changing it to all.